Altair's 2024 Olympic Games are underway, and I'm deeply excited. In this video, we will review how to model and simulate a rock climbing hold under dynamic loading with Altair Inspire and SimLab. We will first create the rock climbing hold in Altair Inspire. With Inspire's CAD creation tools, I can leverage advanced surfacing commands like splines to create the profile of the hold. For dimensions, I worked off a standardized jug hold and created the spline to match the cross-section. I then extruded the spline profile to around 5 inches and intersected it with a half cylinder. Using the advanced Boolean commands in Inspire, I could create the shape I wanted through intersection. My last step was to create fillets which replicate no sharp edges on any of the holds in the games. It's important to note I can apply a variable or continuous fillet to my geometry. The max dimension of my hold is about 5 inches. Now that the hold has been created, I can import it into SimLab to set up the mesh for simulation. SimLab accepts both native and neutral CAD file formats and also allows for advanced import settings. In my case, I'll specify the default settings and import the model. After import, I can easily check my dimensions to validate the geometry. Next, I will set mesh controls to increase the element density for accuracy. In my case, I'll specify a mesh control at the locations where a hand would be gripping the hold during the climbing events. With our mesh controls set, I can create my surface and volume mesh. SimLab enables users to utilize trios, quads, tets, hex, have multiple element orders to aid in simulation. Once the mesh completes, we can check the mesh density through cross-sectioning. Another great thing users can do to check the mesh is the quality checker in SimLab. The quality checker will check various criteria to see if a mesh is a good quality. Additionally, if there's some elements failing, it can identify the location and use a cleanup tool to fix those elements. With the mesh created, I can now apply the boundary conditions for the simulation. Since I'm simulating forces on the hold during a climbing event, I will run a dynamic analysis and specify a time of 1 second. SimLab has a large material library that users can implement on their models. In our case, the model represents an Olympic hold, which is made from a custom polyurethane material, and so I key in the custom properties to represent the polyurethane climbing hold. After assigning the material properties, I can now apply the restraints and loading. I will fix the planar face in all directions to represent the hold on the climbing wall. I then apply the force in our model. I will apply a time-driven load, as this load could represent a climber jumping and grabbing the hold. In our case, the load that I key in is 1,200 pounds, but with the scale factor, the load could increase or decrease across the time of the simulation. With the model set, I can specify my solver settings to run. To get this to run as efficiently as possible, I specify additional cores and only request stress and displacement results. Let's now take a look at our dynamic results on our hold. We can animate results to identify critical locations and easily change result plots or time steps to probe deeper. In our case, we can see our high stress is occurring near the location where a climber would be gripping the hold. We can visualize this result through changing the time steps, querying results, showing min and max values, or isoscaling to see everywhere in the model at a prescribed value. Through SimLab's easy-to-utilize post-processing, I can quickly determine that our hold has not reached a critical stress limit. Thus, our climbing hold is acceptable. Additionally, since this is a dynamic analysis, we can plot how our results change with respect to time. In this case, let's plot stress versus time. We can see that the max stress occurs right at the highest force application with our time-driven load. With the power of Altair CAE tools, I was able to easily model and simulate an Olympic climbing hold. To learn more about Altair Inspire or Altair SimLab, go to www.trueinsight.io.